Our guest speaker today, we have a special guest speaker today, not only a fellow Rotarian, a past president of the Rotary Club of Glendale Sunrise, an honored member of the Rotary Club of Glendale Sunrise, which is one of the best Rotary clubs in the district, tied with Universal City Sunrise, Woodland Hills, and our E-Club. And if our esteemed guests from those other two clubs weren't here, his club would be tied with just one other club. But I have to be polite, which bothers me. Dr. Jorge Vazquez, however, is a top-flight scientist for NASA Jet Propulsion Laboratory. He has a PhD in geological sciences. His focus is undergraduate, and his training is in oceanography. So he's going to throw salt water at you today. We have this in 3D for those watching the video. His focus is on how the oceans affect everything. I don't claim to understand it 100%, but we're getting there, and we're going to explain it a lot more a little bit later. That sound you hear is the ocean lapping up against this location as we speak. So as our usual Sunday food is coming around to us, he also has brought a demonstration today, being a big fan of this, of his Illudium PU-36 explosive space modulator, which he borrowed from Marvin the Martian. So by the end of his talk, there will be a really good earth-shattering kaboom. Ladies and gentlemen, our guest speaker to talk about the oceans, climate, and how all this comes together, please welcome Jorge Vazquez.
Thank you. It really is an honor to be here, and thank you for giving me the opportunity also to talk about this, because it's a subject that I'm very passionate about. What I'd like to do today is give you kind of a brief historical overview of the whole global warming debate, science, if you want to, if we call it that, and then kind of end where we're at and where we're going, where I think the future is going to go. And I'd actually like to go through these slides fairly quickly so we can have time to, because I know hopefully it'll lead to some questions at the very end. So again, I entitled this talk, Global Warming Guaranteed. There we go. I remember this, and I really liked the quote that Mel gave, so this is really appropriate. I remember as a kid, when I first saw this planet, was when Apollo 8, showing my age here, was orbiting the Earth. Was orbiting the moon for the first time, and I think it was Frank Borman that pointed the camera back to the Earth. That was the first time, guys, we saw a picture like this. It was the first time we actually saw our Earth. And I think it really changed the way we looked at our planet. But again, we think that was that long ago. And now, however, we take these pictures, in a sense, almost as an everyday occurrence. We've seen this from satellites. We see this from orbiting satellites. So this has almost become a common day occurrence for us. But it wasn't that long ago, in 1968, that we saw our Earth for the first time. So what started this debate? Well, I'm sure you've seen this plot. It's called the hockey stick plot. This was published by Professor Michael Mann. I don't know if you want to call it famous or infamous, but it's basically a plot of the global mean temperatures. Since this actually goes, actually a little bit bad, I think from the late 1800s, basically almost up to the present. And you see something happening in the late 1800s. Temperatures started to rise. Okay, I don't think there's any. There shouldn't be any kind of skepticism in terms of why this is called the hockey stick plot. Temperatures were stable for a while, and then in the late 1800s they started to rise, and we've seen that general trend. Now, when you look at something like this, please be aware that there are wiggles in this plot. So if somebody comes up to you and says, well, it happened to be cold in Los Angeles on this particular day, therefore global warming can't possibly be happening, we're not looking at one point. It's the difference between weather and climate. It's the difference between the stock market you know, what's happening on the stock market the next day and what's going to be happening on the stock market, the trend over the next 100 years. One is a trend and one is actually literally weather. What's happening the next. You have to understand the differences in these things. One is the wiggles and one is the long-term trend. In terms of the long-term trend, it's very, very clear what's been happening over the last 100 years. And of course, the magic issue in terms of late 1800s that we all talk about, the start of the Industrial Revolution. So what causes global warming? Unlike, this is not, you know, this is not the real cause of global warming, even though I'm sure there's probably a lot of people that think so. But our former vice president is actually not the cause of global warming. There is some science behind all of this. You know. This is another plot that started it. This is the observatory. For those that have been on Mauna Loa in Hawaii, you go to the very top, there's an observatory. Well, one of the things they've been measuring since the 1950s has been carbon dioxide. Now, why is it significant that these measurements are taken in Hawaii? Because basically, the argument that, okay, this is contaminated by the measurements being taken in a city, they're contaminated by pollution, by other things. You can't make that argument. This is an island in the middle of the Pacific Ocean, on one of the highest peaks in the middle of the Pacific Ocean, on Mauna Loa, which is probably the highest peak in Hawaii. So you're measuring literally, this should be representative of what's happening over the atmosphere of the entire Earth. And over the atmosphere of the entire Earth, carbon dioxide is increasing. So again, there's no controversy here, guys. This is the data. This is what the data shows. So again, one of the things you have to realize about this whole debate, you have to be able to separate fact from fiction. Fact, carbon dioxide has been increasing in our atmosphere. Now, if you go further back in time, yeah, I mean, it goes through cycles, and part of the cycle, the cyclical nature of carbon dioxide is when ice retreats or melts during the post-glacial periods, carbon dioxide gets released into the atmosphere. So you do see natural cycles associated with carbon dioxide. However, over the last, several 100,000 years, in terms of what we're seeing today, we're seeing some of the highest values we've ever measured before. Where do we get this kind of data? Again, you get it from sediment cores, you get it from ice cores. There's a lot of science behind this. I don't have the time to go into all of this. But this is basic. There were no satellites 300,000 years ago. Okay? So
that we know of.
That we know of. Yeah, that's a good point, Jim. Yes, that we know of. What's the science behind carbon dioxide? Again, this is physics 101. Okay? A certain amount of solar radiation is hitting the Earth. Actually, we know pretty accurately from the measurements of satellites how much solar radiation is hitting the Earth. Part of that radiation makes it through the clouds, hits the land, hits the ocean, hits the ice. Part of it is reflected back into the atmosphere by clouds. Part of it, again, that gets into the land is absorbed by land, and part of it is reflected and goes back into outer space. However, because of greenhouse gases, part of it is also trapped. Does not go back. Part of the reflected, in a sense, solar radiation that gets from the land and the oceans and the ice doesn't make it back out into outer space. Now, what you want to look at the balances of all of those things, and what you want to be able to do, and they're working very hard, is to actually to use a little bit of scientific lingo, they want to close this equation. They want to close the balance. Can they figure out where is all the heat going? Is the amount of heat that's entering the atmosphere, can we account for all of that? But again, carbon dioxide is a greenhouse gas. There's no debate on that. So what happens to all of this heat? Well, why are the oceans important? Because the oceans can take up 1,000 times more heat than the atmosphere. Guys, there was a famous political strategist has said in the 1990s campaign, it's the economy. Well, in terms of global warming and understanding what's going to happen, it's the oceans. So what role do the oceans play? This is basically a map, a global map of the temperature of the surface of the ocean. Kind of what you would expect. Red is warm, yellow a little bit cooler, and then blue and purple at the poles, even colder. Okay? Now, if you notice, along the western boundaries in Japan and the United States, you have these kind of rivers, almost rivers of warm water that go up from the equatorial regions northward. Those literally carry a tremendous amount of heat. What's the message here? The oceans carry a tremendous amount of heat from one place to the other. The oceans literally control the climate of this planet. Arthur C. Clarke said, and I thought he put it very poignantly, why do we call it planet Earth when it's clearly planet Ocean? And it's actually very, very fortunate for us, because in a sense, the climate of this planet is stable because of the oceans. If it was the other way around, we'd probably be in a lot of trouble right now. Now, one of the questions that people asked, and this is actually, amazingly, it was asked by a former NASA administrator, how do we know that this is the optimum climate? Well, if you look at climate since the start, over the last several thousand years, in fact, since the last mini ice age, which we started to come out of almost 10,000 years ago, if you look at temperature, in fact, the last 5,000 years has been the most stable period of climate that we've seen in recorded history. Now, what's the significance of the last 5,000 years? It's also been when human civilization has literally spread throughout the earth. So is there a correlation between, the optimum climate and human civilization? I think this plot proves it. So you can ask that question, and you can actually determine that climate is important. And, in terms of the optimum climate, it might not tell you exactly what it is, but this kind of plot shows you that at least in the last 5,000 years, human civilization has spread, and it's also been correlated with the most stable period of climate that we've ever had. So, is global warming real? Well, there's been a lot of movies about it. Right? So, sea level rise is actually obviously one of the main big focuses right now. And I'll show you some evidence. I'll try to show you some evidence of where the human factor comes in. Again, this is fairly unambiguous right now. The evidence points that human beings are having an effect in terms of the natural cycle itself. They might not be changing the natural cycle completely, but they are, in fact, accelerating it. And that's the main concern. So, obviously, we can get measurements of sea level rise from floats in the ocean, but we can also get it from observations. Now, if you look over the last 5,000 years, you see sea level has risen since we came out of the last ice age. And however, if you look at the last 100 years or so, sea level has been rising almost 10 times to 100 times faster than it has since the recorded time period over the last 5,000, 10,000 years ago. Now let me say that again, because this is really significant. Over the last 100 years, sea level has been rising faster. Now, if you would expect that it was just all natural causes that were actually to blame for this, you would think that actually sea level would stay stable. It would be very close to the mean that you would get over the last several thousand years. But that's not what's happening. Sea level is actually rising and rising faster. Very, very good indicator that human beings are having an effect. So, again, is there evidence for an anthropogenic cause? By anthropogenic, we just mean a human factor. This is actually taken from buoys over the last, let's see, this is the last 100 years. You can put a straight line through that. The trend is pretty simple. Sea level has been rising over the last 100 years. However, if you look a little bit more closely at that, it not only has been rising, it's been rising faster. So let me just kind of wrap things up. If you look at the satellite record, in fact, the satellite record gives you exactly the same thing. This is amazing. Instruments on the ground are telling us exactly the same thing that a satellite orbiting the Earth 800 kilometers is telling us. Amazing. So when somebody argues, well, the measurements don't mean anything because they're all different, that's not true. In fact, this is the case where it's not true. The satellites literally are telling us to within 0.2 of a millimeter per year. They're telling us exactly the same thing that instruments on the ground. Okay, I'll go through these. What are other concerns that scientists have? We're seeing a lot of melting of sea ice. This is a record off of Greenland. Again, if you look at the sea ice extent during the summertime, shrinking. This is a mission from that's been measuring the sea ice extent again from NASA, the GRACE satellite that can measure the Greenland losing, and the Greenland again is not only losing ice, it's not only losing land ice, but it's losing it at an accelerating rate. Antarctica's losing mass, Alaska's losing mass, so it's a consistent story here. So I end up with where are we going in the future? And this is actually a mission that I'm working on, which is measuring the salinity of the ocean. And the salinity of the ocean, why is that important? Because one of the big concerns is that all of the models tell us is that with a planet that's warming up, it's going to really change the water cycle. Now, why are we interested in the water cycle? Well, all I can say is one word. Look at California. Well, 3 words. Look at California. If we don't think water is important, look at our own home state. anything that changes, the water cycle is critical. And that, if global warming has an effect on that, this is going to be another critical area that scientists are really focusing on. And I'm kind of involved in one of the new missions that hopefully will give us some better idea in terms of what's happening with the water cycle. And I'll take any questions.